Okay, we're ready to start Unit 3. This is a completely new topic. This is not something that most of you would have seen before. So this is Section 3.1, the I can statement as I can understand and use the vocabulary and basic principles of, here's the word, matrices. So we're going to be talking about matrices. So here's how you spell matrices. M-A-T-R-I-C-E-S. So understand and use the vocabulary and basic principles of matrices. So the warm-up here, we've got a couple easy things here. What does the word array remind you of? So if somebody says this word right here, it's kind of a weird word, array. What does that remind you of? Well, for me, because it's so similar, this kind of reminds me of the word arrangement. So let's write the word arrangement. Arrangement. And then a couple of easy things, or they really need to be easy. People confuse these all the time, so make sure you don't. Draw a horizontal line like the horizon, perfectly flat, and a vertical line, of course, would be up and down. People get those confused, so please don't. Now, when we've solved systems of equations, which was what the last unit was about, there were a ton of things that we needed to keep track of. And we started doing the same thing over and over again. So, for example, we were substituting, we were eliminating, we were multiplying equations, we were adding equations, and so forth. And that type of process can be really tedious. It can be time-consuming, and we can be really prone to make some mistakes. But if we keep things neat and orderly, that can help us reduce the number of mistakes that we make and the number of things that we need to keep track of. And one tool that mathematicians use to organize information is called a matrix. So let's write the word matrix right here. Now, you've probably heard the word matrix before. The plural of that is matrices. So when we were talking about matrices up in the I can statement, that's what we were talking about. It's the plural of matrix. So let's talk about what a matrix is. So I've got a couple of vocabulary words here. A matrix is a rectangular array of numbers or variables. It's organized in horizontal rows and vertical columns, and it's usually enclosed in square brackets. So the square brackets are going to look something like this. So over here, and I know this seems silly, but you've got to make sure that you remember that the rows come horizontally and the columns come vertically. So rows like this, columns like they're holding up a roof or something like that. Now, inside a matrix, we've got what are called entries or elements. And the entries or elements are the individual numbers. So let's write down numbers. Individual numbers or variables. It can have variables in there. The individual numbers are variables inside the matrix. And then the dimensions of a matrix, those are the number of rows. Let's write rows right here by the number of columns. That's always going to come second. The last vocabulary word here is indices. Indices are the subscripts that indicate the position. So position of the entry in the matrix. And like I said before, the rows always come before the columns. So the number of the row is going to come before the number of the column. So let's take a look at a quick example right here. And let's point out how each one of these vocabulary words comes into play. So this right here, this arrangement, this rectangular arrangement of numbers, that's a matrix. So in this case, I've called this matrix A. So I wrote A equals, and then we've got these square brackets here. And I've got 6 numbers altogether. So in the first row, we've got -4, 5, and -6. And in the second row, we've got 1 and -2 and 3. So this actually has 2 rows. So we're going to write 2 right here. And it has 3 columns. Remember, the columns run vertically. So the first column is -4, 1. The second column is 5, -2. And the third column is -6, 3. So this has 3 columns. So the dimensions of that matrix, or the dimensions of A, are 2 by 3. Now we write a tiny little X like that and we say the word by. So this is a 2 by 3 matrix. And the element in the first row and third column is indicated. So this is the first row right here. It's in the third column. So this -6 right here is in the first row, third column. So we use indices to represent that, or those are subscripts. So we write 1, 3. So the A13 represents the entry that's in matrix A. It's in the first row and the third column. So off on the side here, it says, what entry is the A21 entry? So this would mean the second row and first column. So let's come over here, second row, first column. That's going to be this right here. That would be the number 1. Notice that there's only one number 1 here. Okay, and the reason is it's in the second row. It's in the, second row, not raw. Second row, and it's in the first column. first column. So the number that comes first is always going to be a row. The number that comes second is always going to be a column. Just like over here, the number of rows in the dimensions of the matrix comes first. The number of columns in the dimensions comes second. So let's take a look at example 1. And here's what they want us to do on number 1. It says identify the dimensions and the A21 entry for each of the matrices below. So we've got this matrix right here. We've got 1, 2, 3, 4. We've got 5 different matrices that we're dealing with here. So the first thing we're going to do is we're going to write down the dimensions. So on this one right here, we're going to write down the dimensions are, let's see, so this would be 2 rows and 1, 2, 3 columns. So this is a 2 by 3, again, just like the one up there. And we want to find the A21 entry. So the A21 entry is going to be in the second row, first column. So again, that's going to be right there. So that's going to be -3. We're just writing down the number that's in that position there. So on the next one here, this one is, let's see, what have we got here? We've got 3 rows. So this is going to be a 3 by 1, 2, 3. This is 3 columns, so 3 by 3. And because it has the same number of rows as it does columns, we call this a square matrix. So we call that a square matrix. Now let's find the A21 entry. Again, the A21 entry is going to be in the second row, first column. So this is second row right here, first column right here. So that's going to be a 4. All right, let's take a look at this next one. This one looks a little bit weird. It's kind of small. This one is called, because it only has one column, this is called a column matrix. And it's got 1, 2, 3 rows. And it's got just one column. So this is a 3 by 1. So if that second number is ever just a 1, we call that a column matrix. And let's find the A21 entry here. So we need the second row and first column. So we need the second row and we need the first column. So that's right there. So that's going to be a 16. So we've got that one taken care of. Now, if this one was called a column matrix, you want to take a guess at what this one's called? This one is called a row matrix. So this has only one row and it has 3 columns. So this is a 1 by 3. So this one was 3 rows and 1 column, so 3 by 1. This is 1 row and 3 columns, so this is a 1 by 3. Now, if we wanted to find the A21 entry here, we need the second row and we need the first column. There is no second row, so we're just going to write NA for not applicable. It doesn't work on this particular one. Okay, and then we take a look at this last example right here. This one has 2 rows and 2 columns, so this is a 2 by 2. It is a square matrix, but you'll notice that every single one of the entries is a 0, so we call that a 0 matrix. If all the entries are 0, we call that a 0 matrix. And then, of course, we want to find that A21 entry, second row, first column. It's going to be this one right here. So this one's going to be, of course, a 0. Now, it's going to seem a little bit silly, but almost everything that we do with matrices is going to depend on your ability to correctly identify the dimensions of a matrix. So you've got to make sure that you're writing down the dimensions correctly, identify how many rows and how many columns there are, and the position of individual entries. Entries, or again, we could call those elements also, along with those subscripts. So these little numbers that we have right here, the subscripts on the indices, writing down the dimensions, they are not trivial things. They are unbelievably important when we're dealing with matrices. So you've got to make sure that you pay attention to those and make sure that you get those right. So hopefully those 5 examples were good there for you. Let's talk about equal matrices. So if we have equal matrices, they've got to have the same dimensions. So you've got to make sure they have the same dimensions first, and they've got to be equal element by element. And when we say element by element, what we mean is we're going to check the corresponding entry of one matrix against the corresponding entry of the other one. And if those aren't equal, then there's no way that we've got equal matrices. So in example 2, it says determine whether the pair of matrices are equal or not. If they're not, state why they're not. So the first thing we have to do is we've got to make sure that they have the same dimensions. If they don't have the same dimensions, there's no way that they can be equal, because we've got to go through and check element by element. So this one is, let's see, 1, 2, 3. This is 3 rows and 2 columns. This one is 2 rows and 3 columns. So are these equal? The answer to that is no. So we're going to put a big no here. And the reason is not same dimensions. Okay? Not same dimension. Whoops, dimension. Spell that correctly. Okay, dimension there. And that would be enough to say that right there, but I just want to point out why there's no way that these could be equal. So if we go through here and we check this first row, first column, that's a 2. First row, first column, that's a 2. This one is a 4, first row, second column. That doesn't match up with that one, but if we take a look here, there's nothing to match up with over here with this 4 right there that's in the first row, third column. There's no third column to match up with there. So that's another reason that we could say why there's no way that those could be equal. So if we take a look at this next one here, again, we've got to check the dimensions first. So they've got to have the same dimensions, 1, 2, 3 rows by 1, 2, 3 columns. So this is a 3 by 3. Taking a look over here, you can kind of tell just by looking at that. 3 rows, 3 columns, so that's a 3 by 3. So that's not enough to say that they're equal because we've got to go through and check element by element. Now I made this one fairly easy. We've got a 1, 2, and 3. Check 1, 2, and 3. 4, 5, and 6, 4, 5, and 6. So what we're doing is we're going through and checking all 9 elements here and making sure that they're in the exact same place and the exact same number over here. So the answer on that one is yes, those are equal. Now if we take a look at this one right here, it's got an asterisk, so we kind of want to be careful here. Let's notice that this has 2 rows and 2 columns, so this is a 2 by 2. This looks kind of ugly, but this still has 2 rows and 1, 2 columns. Okay, so let's go through and check. Now this is a 1, and we're saying that that's got to be equal to the square root of 1. Well, it is equal to the square root of the 1, so we've got that element taken care of. Does 2 equal this one over here? Well, it looks different, but 6 divided by 3 is 2, so those match up. This one's a 3. Is that the same as the square root of 9? Square root of 9 is 3, so we're okay. So we've checked 3 of the 4 elements. We're now down to the last one. We want to make sure that 8 is the same as 2 to the 4th. Is 2 to the 4th the same as 8? The answer to that is no, because this would be a 16. So this is no. And we'd say 8 is not equal to 16, or 2 to the 4th is what we had there. Okay, so again, dimensions have to be the same, and then we check every one of those elements, make sure that the same number is in the same position on each one of those. Okay, next one, example 2 star. It says, could these matrices be equal? If yes, how? And if no, why not? So let's take a look at this one right here. Again, you've got to check the dimensions. This has 1 row, 1, 2, 2 columns, 1 row, 2 columns. Okay, and then what we check for is we'd have to make sure that those 2 are equal. So 2y would have to equal 8, and these 2 would have to be equal. So 6 would have to equal 2x. So that means that x would have to equal 3, and let's see, this would mean y would have to equal 4. Okay, that's the only way those could be equal, is if we plugged in the right number into each one of those. So if yes, the answer here is yes, and this is how it would be. Okay, so I'm just going to write a yes there to make sure we're clear. So the answer is yes, they could be equal, and that's what would have to happen. The y would have to equal 4, and the x would have to equal 3. If we take a look at this one, let's see. This is 2 rows, 1 column, 2 rows, 1 column. And in order for these to be equal, 3x would have to equal 9, and negative 5y would have to equal 15. So x would have to equal 3. And let's see, if we divide by negative 5, that would be negative 3. So the answer here is yes, and we'd have to have x equal to 3 and y equal to negative 3. All right, let's take a look at this one. Now, this gets a little bit interesting right here, because on this one, let's see what we've got here. This is, we've got 2 rows, we've got 1 column. Now take a really good look at this. Okay, and this is something that takes a little bit of getting used to when you're dealing with matrices. If there's a plus or minus here, this whole thing is stuck together. All right, so we've got a 1 and a 2 and a 3. There's nothing in between there. Each one of those is a separate element, but if we've got an operation, those 2 are stuck together. So that's 1 element right there, and that's 1 element. So this is 2 rows, okay, and this is 1 element, and that's 1 element, so this is a 2 by 1. So what we get here is we get y would have to equal 3x minus 2, and the other one says that 3 would have to equal 2y plus x. Okay, now the answer on that is yes, and we'd have to go through and we'd have to solve that system of equations in order to figure out what it is. So because we know how to solve systems of equations really well, I'm not going to take the time to do that right now, but you could go through and solve that. You'll notice that this one is set up for substitution. You could solve that, figure out what x is, and then plug that back in and figure out what y is. So let's turn our attention to this one right here. This one is like the one over here. This one is 2 rows and 1 column. Okay, this is 2 rows, and this is 1 column here and 1 column there, so this is a 2 by 2. So there's no way that a 2 by 1 can be equal to a 2 by 2. There are 2 entries in here, and there are 4 entries in there. There's no way to match them up so that they're all equal to each other. So the answer there is no, and we're going to say not same dimensions. Not same dimensions. Okay, let's flip the page over and let's see what we've got here on this other side. So I'm hoping that you found the examples on the other page fairly easy. This is where matrices get really useful. They help us organize large data sets. So if we've got a ton of information to keep track of, matrices can come in really handy. And we're going to learn how to do some operations with matrices. But for right now, all we're going to do is we're just going to practice organizing the information into a matrix. So although this looks like a really long problem, I'm hoping that this turns out to be fairly easy to organize into a matrix. So here's the deal. A travel agent offers 3 different travel packages to Orlando. Package A consists of 4 nights of a hotel and 3 passes to local attractions, and 5 meals are included with that package. So they get hotel, passes, and meals with package A. Package B, 3 nights of hotel, 4 passes to the parks, and then 7 meals. And then package C is 5 nights of hotel, 4 passes, and no meals at all. Okay, and it says the agent can book a hotel room for $150 per night, guest passes for $100 each night, and provide a meal for $15 each. It says organize the data into 2 matrices, with the first one indicating the number of items and the second one indicating the prices. So here's what we're going to do. We've got 3 different packages, and we've got nights, passes, and we've got meals. So this is what I'm going to do. If we have 3 different packages and we've got 3 different things within each one of those packages, I'm going to do the package right here. So I'm going to do A and B and C. I'm going to do the packages there. And then we're going to do the hotels, and we're going to do the passes, and we're going to do the meals like this. So for package A, it's going to be 4 nights of hotel, 3 passes, and 5 meals. For package B, it's going to be 3 nights, it's going to be 4 passes, and 7 meals. And then for package C, it's going to be 5 nights, 4 passes, and no meals. So 0 right there. All right. Now, it says the agent can book the hotel for $150 a night and the passes for $100 and provide each meal for $15 each. So here's what we're going to do on that. Now, there are a couple different ways that we could do this. I'm going to go ahead and put this as a column matrix. So we're going to have, this is going to be the hotel prices, this is going to be the pass prices, and these are going to be the meals. So this is going to be $150 a night right here. It's going to be $100 for the passes, which I hear things are crazy at Disney World, really expensive to go there, and then $15 for each one of those. So this one represents the cost of each one of these, and then this one represents the items that are included in the package, okay? Now, that's all that's required here. In fact, if you wanted to, although this is good information, you really don't even have to put these guys over here. The answer to this problem is just this matrix right here. This represents the item, and this matrix right here, that represents the cost of each one of those items. Okay, let's take a look at this next one here. And again, all we're doing is practicing taking information and then writing it down in a matrix. So on this one, it says Caitlin wants to attend one of 3 universities next year. Tuition at the U of U is $85.18. Room and board, so that means how much you paid for where you live and eating and that sort of thing, is $87.50. And the student enrollment is $32,760. And then she's got the same type of information at BYU and UVU. So when you're interested in going to a school and knowing kind of the characteristics and stuff like that, it's a good idea to know how much it costs. It's also a good idea to know how big the university is. And in this particular case, it looks like they're all fairly similar. So this is what I'm going to do. I'm going to set up a matrix. And she's got 3 different matrices, and 3 different universities. So I'm going to use a different row for each one of those. So the U of U is going to be $85.18 for the tuition. Room and board is $87.50, and then I'm going to need to move this out because that's not quite big enough. So $32.76. So $760 for the enrollment. So this represents the U of U. This next one's going to represent BYU. So it's $5,300 for tuition. Pretty cheap there. That's not bad. $75.30 for room and board, and then the enrollment a little bit bigger, 33,517, and then UVU is 5530. Let's see, room and board, wow, really cheap there, 3870, and the enrollment, wow, look at that. That is a big university, 282. Okay, now, so U of U's here, BYU's here, UVU is right there. Again, all it said is organize this into a matrix, and then it does say be sure to indicate the dimensions. This would be a 3 by 3, and I want to make sure that I didn't miss that on the last one there, so let's go back up here and check. Let's see, indicate the dimensions. So this one is going to be a 3 by 3, and this one over here, 3 rows and 1 column, so that would be a 3 by 1. All right. So that is how we translate from a story problem in context, how we can organize that information so that it's nice and organized in a matrix. And that's what it is, a rectangular arrangement of numbers. So go ahead and do the self-assessment and get started on the assignment.